In this video, we are going to learn about the characteristics of polynomials. So let's start with domain. The domain of a function is describing the x values, which on a coordinate grid are the left and right values of our graph. So when we use interval notation, which uses parentheses and brackets, you're going to have two numbers that look like a coordinate, but instead it's not a coordinate. We're describing how far left the graph goes and how far right the graph goes. Oftentimes, you'll see it as negative infinity to positive infinity, something like that. Okay, so let's move on to range. The range is similar to domain, where it's going to describe a specific part of the graph, and this is going to be the y values. What are the possible y values of the graph? And generally, this is going to talk about the lowest point up to the highest, or the highest to the lowest, but you'll always describe the range from the furthest down of your graph that it goes to the farthest that it travels up. Once again, it looks like a coordinate, but it's not. Okay, so let's talk about the end behavior of a graph. The end behavior is actually talking about the little ends of the graph. So the arrows that we draw on the ends whenever we're sketching polynomials or other graphs, they can go in the same direction, down, up, different directions, but we'll describe things in terms of x and y. So what we'll usually say is as x approaches negative infinity, and remember, if we're traveling on a coordinate grid and we're talking about x going to negative infinity, that would be towards the left. So really we're just saying if you look to the left, or as you look to the left, we'll then say, well, y either goes up to positive infinity or it goes down to negative infinity. So you'll pick one of those. It'll be one or the other. Similarly, we have to describe the right side of our function too. So I would say as x approaches positive infinity, or as x goes to the right, if you look to the right on your graph, is the end pointing up or down. So we would say y approaches positive infinity if it's pointed up, or negative infinity if it's pointed down. All right, let's move on to relative extrema. So extrema of a graph are describing the highest points and the lowest points, or the peaks and the valleys, however you want to describe it. Okay, the peaks would be considered maximums, and the valleys would be considered minimums. Okay, it's possible to have multiple maximums and multiple minimums, especially when we're looking at polynomials. Relative extrema means all of them, every single maximum and minimum. For absolute extrema, we are talking about the actual absolute highest or lowest point. So in this little graph, we only have one. It is the highest or lowest point on your graph. Okay, so let's talk about the increasing interval. Increasing interval is talking about when your graph is going up. So if you were to trace the graph from left to right, so you start on the left and you trace it, is your pen going up or is it going down at each point? So on this graph, it goes up and then it goes down and then it goes up. So it has two increasing intervals. Okay, so we're going to use the x values to describe this. Specifically to describe where the function is going up. Similarly, the decreasing interval is talking about if you were to take your pen or pencil and you were to trace the graph, go up. Is your pen going up or is it going down? Or is it going up? In this graph, it's going down in one section. Okay, so once again, it's going to use x values to describe our function goes down. Okay, one more thing to cover. Parentheses or brackets. Now we'll practice using these, but typically brackets are going to include the value, or it's actually possible for your graph, it actually includes that point, it touches that point. Parentheses does not include the value. So for reference, infinity will always have parentheses because you can never reach infinity. It's a journey, it's not a destination, right? It just keeps going forever. So we have parentheses there. Okay, so let's go ahead and practice with a polynomial function. So we have a lovely polynomial. The domain, as we can see, we have arrows on the ends of our graph. That indicates that it goes left forever, and then it goes right forever. So our domain goes left forever, it goes to negative infinity, and then it goes right forever, it goes to positive infinity. For the range, we're talking about the lowest that our graph goes. So the lowest would be this number here at negative 3.5. So the lowest this graph goes is negative 3.5. And then it goes up forever, right? We can see with our arrows, it goes up forever to infinity. Infinity always uses a parenthesis. However, in this case, I'm going to use a bracket on the 3.5 because it actually travels to negative 3.5. That is a point on our graph. Okay, end behavior. Remember that's talking about these little ends. What are these little guys doing? Well, I have to describe the left and then the right. So let's describe the left. Okay, I would say as x approaches negative infinity, or as x goes to the left, y, well, this guy is facing up, so y goes to positive infinity. Okay, let's do the other side as well. Also pointed up, so as x approaches positive infinity, or as I look at the right end of my graph, y is also, yep, it's pointed up, so it goes to positive infinity. Okay, for relative extrema, we've got 3 maximums and minimums altogether. So I'm going to list all of them. I've got negative 0.4, negative 3.5. I also have 1.4, comma 0.5, and 2.6, comma negative 0.6. But I only have one absolute minimum in this case, which is at negative 0.4, negative 3.5. Okay, on to the increasing intervals. So I'm going to trace my graph, and if my pen's going down, then it's got to be a decreasing interval, and if it's going up, then it will be an increasing interval. So from here to here, this is a decreasing interval. Decreasing, it's going down. And then it changes directions, and it goes up. And then it goes down again. And then it goes up again. In the positive direction. So increasing intervals, I have 2 different intervals. So let's start with our first interval. Right here, this little slice. Now remember we use x values to describe these intervals. And the x values are on the x-axis. Or I'm using the x values of my coordinates. Okay, so the first interval is between negative 0.4 and it goes to 1.4. Okay, and then I have another interval, right? It increases for this section of the graph too, or everything to the right of this x value, which is 2.6. So from 2.6 to infinity, it will be increasing. And then I'm going to put a u for my correct set notation between them. Okay, for the decreasing intervals, I've got everything to the left of this x value here. Okay, everything to the left. So if I looked to the left forever, I'd see negative infinity, and then it will decrease, and it will stop decreasing once it gets to negative 0.4. And then it's going to decrease between 1.4 and 2.6 in this section, right? It goes down again. So it also decreases from 1.4 to 2.6. I'm using parentheses on purpose for all of these, not brackets, because at the minimums and maximums, our graph, our function, is not increasing or decreasing. Okay, let's do one more practice problem together. I can see that my graph goes left forever, it goes right forever, so my domain is from negative infinity to positive infinity. This time my function is pointed downwards, so the lowest it will travel, it goes down forever. So I've got negative infinity for the farthest down that it goes. For the highest up that it goes, I've got a maximum here at 48. So I use my y value 48. It does actually equal 48, so I'm going to put a bracket on the 48. Next, I have end behavior. I know that as x approaches negative infinity, y, well, it's facing downwards, so y approaches negative infinity. And as I look to the right, or as x approaches positive infinity, y is, well, it's also facing down, so y approaches negative infinity. I have 3 maximums and minimums, so I'll list them all for my extrema. But my highest, I have an absolute maximum at 2.948. Okay, increasing intervals. It is increasing here. So everything to the left of negative 2.3, and then it stops increasing at 2.3. And then it's going to start increasing again once I get to 0, and then it'll stop increasing at 2.9. So I've got from 0 to 2.9. For decreasing, it travels down between negative 2.3 and 0, and then it increases again, but once I get to 2.9, it decreases again, so I have 2.9, and then it just keeps decreasing forever. Thanks for watching!